Good day, everyone. I am Denmark B. Etorma, your candidate number 10. Today, I will be continuing Eliza's report by focusing on some of the most influential mathematicians in the 18th century. The three L's. First is Joseph Louis Lagrange. So, Joseph Louis Lagrange is already discussed by Ms. Gamutin. Second is Pierre-Simon Laplace. He was immensely influential French mathematician and astronomer. He is sometimes referred to as the French Newton. He was nicknamed this for using advanced calculus to prove the long-term stability of the entire solar system, completing Newton's work on gravity. Monumental work, Celestial Mechanics. This was his 5-volume masterpiece that systematically applied calculus to astronomy, creating a unified mathematical description of planetary motion. Developed his own version of the so-called Bayesian interpretation of probability. He formalized the statistical method of using prior knowledge and updating beliefs with new evidence, a foundation of modern statistics and data science. Third is Adrien-Marie Legendre. He was an important French mathematician known for major contributions to number theory, elliptic functions, and the method of least squares. The first 6 Legendre's polynomials, solutions to Legendre's differential equation. So these are specific functions used in physics and engineering that solve Legendre's differential equation when problems are analyzed in spherical coordinates. The elements of geometry. This was Legendre's highly influential 1794 textbook that provided a simplified, modern, and rigorous adaptation of Euclid's work, becoming a standard text of 4 generations. Next is the other 18th century mathematicians. First is Leonard Paul Euler. He was a prolific Swiss mathematician and physicist, considered one of history's greatest mathematicians. He excelled in all aspects of mathematics. Euler made foundational contributions to nearly every branch of mathematics known in his era, including calculus, number theory, and geometry. His genius was so profound that other mathematicians famously advised, "Read Euler, read Euler. He is the master of us all." He introduced or popularized much of the notation used in mathematics today. Euler standardized essential mathematical notation. F of x, he was the first to consistently use f of x to symbolize a function. For summation, he introduced the capital Greek letter sigma to represent the sum of all series of terms. Second is Christian Goldbach, a German mathematician who proposed the Goldbach conjecture, which states that every even integer greater than 2 can be expressed as the sum of 2 primes. For example, 4 is equal to 2 plus 2 and 8 is equal to 3 plus 5. So this is the famous and proven conjecture that every even integer greater than 2 can be expressed as the sum of 2 prime numbers. So every integer greater than 5 can be expressed as the sum of 3 primes. A so-called weak Goldbach conjecture states that all odd numbers greater than 7 are the sum of 3 odd primes. So this is a related conjecture concerning odd numbers. A version of this conjecture states that every odd number greater than 5 is the sum of the 3 primes. This conjecture was largely proven by Harold Helfgott in 2013. The third mathematician is Abraham de Moivre. So Abraham de Moivre is a French mathematician known for probability theory and complex numbers. So a French mathematician best known for de Moivre's formula, cosine x plus I sine x times n is equal to cosine times n x plus I sine times n x, which links complex numbers and trigonometry. So this fundamental formula links complex numbers and trigonometry and inessential for working with powers and roots of complex numbers. Generalized Newton's famous binomial theorem into the multinomial theorem. So he expanded Newton's binomial theorem into the more general multinomial theorem, which describes the expansion of powers of sums with more than two terms. Pioneered the development of analytic geometry and gave the first statement of the formula for the normal distribution curve. So he pioneered probability theory and was the first to state the formula for the normal probability distribution curve, also known as the bell curve, a central concept in statistics. Fourth mathematician is Gaspard Monge. He was a French mathematician and the founder of the École Polytechnique, the inventor of descriptive geometry. Monge invented descriptive geometry, a method used to represent three-dimensional objects in two dimensions. This technique, crucial for engineering, architecture, and manufacturing, uses orthogonal projections to provide an exact and clear way to design and build complex objects. Fifth is Johann Lambert. He was a Swiss mathematician, physicist, and astronomer known for significant contributions to map projections, philosophy, and mathematics. A Swiss mathematician and prominent astronomer who finally provided a rigorous proof in 1761 that pi is irrational. So Lambert provided the first rigorous proof that pi is an irrational number. This means that pi cannot be expressed as a simple fraction of two integers, a foundational result in the study of transcendental numbers. The last mathematician is Ferdinand von Lindemann. He was a German mathematician renowned for a landmark proof concerning the nature of pi. He proved that pi is also transcendental. It cannot be the root of any polynomial equation with rational coefficients. So, this means that pi is not the root of any non-zero polynomial equation with rational coefficients. This proof solved the ancient geometric problems of squaring the circles, showing it is impossible to construct a circle with the same area as a given circle using only a compass and straight edge. And he was the first to introduce hyperbolic functions into trigonometry. So in conclusion, the 18th century was a powerful era for mathematics, marked by extraordinary thinkers who shaped the foundations of modern mathematical ideas, from the influential Bernoulli family to the brilliant works of Lagrange, Laplace, Euler, and many others. This period produced groundbreaking discoveries in calculus, probability, geometry, and mathematical physics. Their contributions continue to influence today's scientific studies, engineering, innovations, and even everyday problem solving. The advancements they introduced remind us that mathematics is a growing and evolving field built on the dedication and curiosity of great minds. And that would be all. Thank you.